Okay, let's have a look at the ester functional group. All esters contain this complex. Let's break it down. So we have an R group coming into a carbon, and if we look at this carefully, we've got a double bonded oxygen with a single bonded oxygen, and this is very similar to our alkanoic acid. So we can think of it that way. We've also got, on the right-hand side, something like that, which is very similar to our alkanol. And in fact, esters are made from a combination of alkanoic acids and alkanols. We find esters in many types of foods, and they're the sweet-smelling compounds. They've been made artificially in the last 50, 60 years, and they often provide the smells that we find in confectionery. So the banana smell or the raspberry smell or the strawberry smell comes from an ester compound. So how do we go about naming an ester? We need to look for the carbon chain that contains this particular group. And this will form the suffix which we name alkanoate. So we substitute this for our particular alkane. We also need to name the other carbon chain with a substituent group, so an alkyl group. So let's take a molecule down the bottom here. If we look at it, our first step says to look for the carbon chain that contains this particular group, our ester group. So in this case, we have that part of the molecule there, which, if we count the number of carbons, 1, 2, 3, 4, it's going to be a butane, and we said in our first step that it ends in this OATE suffix. So we add the OATE on the end. We then look for the other group coming off this molecule, and we call it the alkyl group. So in this case, I have my alkyl group here, which is a methyl group. So we call this molecule, this ester, methyl butanoate. Now you'll notice that I have a space in between my two parts of the name. We do that because it's a derivative of our alkanoic acid, which also has two words. Okay, so how do we prepare an ester? As I said before, we need an alkanoic acid and we need an alkanol. And if we put those two molecules in the presence of an acid catalyst and we provide heat to the system, we produce our ester group. You'll also notice that I've produced water in this particular molecule as well. From our alkanoic acid group, we produce the alkanol group or the hydroxy group, and from our alkanol, we produce the hydrogen. So we get the OH combining with the H to give us our water. Now this particular type of reaction is a very common reaction in organic systems, and it's commonly known as a condensation reaction because it produces water. It's also known as an esterification process. We've produced the ester, which is this particular linking system here, and it's quite common in biological systems to find that particular reaction. Now we can get the reverse reaction with exactly the same conditions. So we can start with our ester group, we can put it into a system with water, in the presence of an acid catalyst, once again provide the system with heat, and we split apart our two molecules into our alkanoic acid group and our alkanol group. Now because this is a reversible reaction, it means that these molecules can be formed and broken down quite easily in nature.